1.1 Lesson 8 Conservation of Matter. Elements combine and recombine, but are not destroyed in chemical reactions. Chemists keep track of what is going on in chemical reactions by using symbols and formulas. In this way, specific elements can be tracked through a series of chemical procedures. Tracking the elements provides evidence that new substances are simply rearrangements of the original substances. As a result of this lesson, you'll be able to explain that the product of chemical reactions depends on what was present at the time of reaction, and explain that matter cannot be created or destroyed in a chemical reaction. Take a few moments to pause and look at this diagram of the copper cycle so you can see what happened to the copper throughout the experiment. Go over the experiment one step at a time and look to see what happens to the copper after you add the nitric acid, when you add the sodium hydroxide, when you heat and filter. Look at each stage and determine what is the chemical formula of the copper compound that was created. The law of conservation of mass states that matter cannot be created or destroyed. When elemental copper is tracked through a series of reactions or chemical changes, the symbol Cu shows up in the formulas of the new compounds that are made. Therefore, elemental copper can be combined with other substances to form new compounds, but it is not destroyed as a result. This is true of all the elements in the copper cycle, even though we are focusing on copper. You could prove that copper was not destroyed by measuring the mass of the copper powder at the beginning and at the end of the experiment. If you did the experiment perfectly, you would end up with exactly the same amount of copper powder that you started with. However, in real life, the mass of the copper at the end of this experiment is a bit less than the mass of the copper at the beginning, due to several factors. Little amounts of copper are lost along the way, either because of spills or measurement errors or the copper staying stuck to the filter paper or beaker. In addition, not all the reactions go to completion, so some copper remains in compound form. Nevertheless, mass is still conserved. Even if the original copper didn't end up in the beaker at the end, it still exists somewhere. No matter what was done to the copper, it was not broken down any further. We were able to track the copper through all its transformations using symbols for the elements. At the end of the experiment, the copper was returned to the form we started the experiment with, solid copper. This experiment provides evidence that elements cannot be broken down or destroyed. The observations we have made in the copper cycle lab provide further evidence that the golden penny is not gold. Gold and copper are both elements. As elements, each is unique and cannot be broken down into simpler substances or destroyed. If gold is an element, then we probably will not be able to convert copper into gold by reactions similar to those carried out in the copper cycle lab. To wrap up this lesson, what happens to elements in a chemical change? Elemental copper can be transformed through chemical reactions or chemical changes and then recovered. We can represent elements with symbols and keep track of them during chemical reactions. Elements combine and recombine, but are not created or destroyed in chemical reactions.